So today we're going to do a quiz on chapter 2, free fall. But before we start the free fall, we'll do a couple of problems on linear motion in the x direction for review. Don't forget, whenever I say stop the tape, stop it and try to work it out yourself before looking at the answer. So the first problem is this one here. A Cessna plane has a liftoff speed of 120 kilometers per hour. What's the acceleration it would need to be airborne after 240 meters? So basically it starts off with zero initial velocity here. It accelerates and it needs to reach in 240 meters over here a speed of 120 kilometers per hour. Since we work with meters per second, you have to change kilometers per hour to meters per second. That's 33 1/3 meters per second. So stop the tape and see if you can work it out. So the equations that we're going to use come from this batch, constantly accelerated motion. And the one that we're going to use to solve this problem, given this information, the initial velocity is 0, delta x is given. Okay, delta x is 240 meters. We want to find the acceleration. And the final velocity is 120. So when it gets over here, its velocity is 120. So these three things are given, and we're looking for, I'm sorry, not 120, but 33 1/3, 33.3 meters per second. So this is the equation we're going to use. V final squared, which is that number squared, equals V initial squared, which is 0, plus 2a delta x being 240. And if you solve this equation for a, you will get this answer. Okay, so and the next question, a car travels from rest, moves with constant acceleration of 2 meters per second squared for 10 seconds. And then it moves with constant speed for 10 seconds, and then finally slows to a stop with constant acceleration of minus 2 meters per second squared. How far does it travel during all this time? So stop the tape and see if you can figure this out. I'll give you a hint. It's easier to sketch a graph of the motion before you even start. The graph of the motion looks something like this. So this is the first part of the motion. It speeds up from 0 to 20 in 10 seconds. Then it moves for another 10 seconds at constant speed, and then it slows down. So this is basically three equations. We have to use the average velocity here, the average velocity here, and the average velocity here to find the distance it went. So coming back, or instead of average velocities, you could have used this equation. So the first one I'll do with using that equation. What's the acceleration? And the acceleration you find from the graph, you're going from the acceleration you're given is 2 meters per second squared. So you can use this equation. During that first 10 seconds, it goes that distance. During the second 10 seconds, it travels at a constant speed of 20 meters per second for 10 seconds, so it goes that distance. And for the third part, we'll use the average velocity. Note that the car starts at 20 meters per second for 10 seconds because it's accelerating from 0 for 2 meters per second every second for 10 seconds. That means it's traveling 20 meters per second when it gets here, right over here. And then this is 20 and this is 0, so the average velocity is 10 during this time. So you can use that, and that'll give you 100. Of course, the other way to do this is to find the area under each of these parts. So the first area is 1/2 base times height. That's this triangle over here. The second area is this rectangle over here, so it's length times width. And the next triangle has the same area, so the total distance is 400 meters. So the answer to this question is 400 meters. You can see to get the same answer here, 100 plus 200 plus 100 is 400 meters. Okay, let's go on to free fall problems now. You throw a ball straight up into the air after it leaves your hand. At what point in its flight does it have maximum value of acceleration? Stop the tape and see if you can answer the question. Well, its acceleration is constant. If it's in free fall, acceleration is g. Whether it's going up or down, acceleration is always g. Alice and Bill are at the top of a building. Alice throws her ball down. Bill simply drops his ball. Which ball has the greater acceleration after release? Stop the tape and see if you can answer the question. Well, neither. They both have the same acceleration. G is their acceleration. One is just starts at a higher number. If it's thrown down, it starts at some number and increases by 10 every second. If it's dropped, it starts at 0 and increases by 10 every second. So which one has the greater velocity when they hit the ground? Well, Alice's, because it starts with a big number and that increases every second. You throw a ball straight upward with initial velocity of 10 meters per second, assuming there is no air resistance. What is its speed when it returns to you? Stop the tape and see if you can answer the question. Well, the speed will be the same as when you threw it up, except it will be down, but speed doesn't have direction, so it's just 10 meters per second will be the speed. A ball is thrown straight up from point A, then to point B, then to point C. Which of the following is true about the direction of the ball's velocity and acceleration between A and B? That means while it's going up from A to B. What is true about the direction of this velocity and acceleration? Which vectors show the proper? Stop the tape and see if you can answer the question. Well, as it's going up, the velocity is going to be up, but the acceleration vector is always down. So velocity will be up, acceleration is down. How about between B and C as it's coming down from B and going down to C? Which graph gives you the proper directions of the velocity and acceleration? Stop the tape and see if you can answer the question. Well, the answer is D. Obviously, velocity is coming down, so the velocity is going down, getting bigger as it drops down. And as we said before, acceleration is always down. An object is thrown straight up with initial velocity of 50 meters per second. How long to get to its highest point? Assume g is 10. Stop the tape and see if you can answer the question, and here are the equations. So we know that we're going to use the first equation over here. Final velocity is equal to initial velocity minus gt. Let me just fix this a little bit here. So the final velocity when it gets to the highest point is 0. The initial velocity is 50. And using 10 for g, it'll be minus 10t. Solve that equation for t, and that'll be 5 seconds. T is 50 divided by 10. You could have done that in your head, just remembering that it starts at 50, it loses 10 every second, so it would be 5 seconds before the velocity becomes 0. How high does it go? Stop the tape and see if you can answer that question. How high does it go? So we're going to use two ways to do it, right? One is we're going to say the average velocity when it goes from here to here. This is v is 50, and this is v is 0 at the top. And the average velocity, therefore, is going to be 25. It's 0 plus 50 divided by 2. And we calculated before it's going to take 5 seconds, so that's 125 meters. Or we could have used the equation that the distance, or the height, or delta x, we want to call that, delta x, delta y, I'm sorry, it's the height, is equal to v naught t minus 1/2 gt squared. V naught being 50, t now it's 5 seconds, and that gives you 125 meters also. An acorn falls from an oak tree. You know that it takes 2.5 seconds to hit the ground. How fast was it going when it hit the ground? Stop the tape and see if you can answer the question. And here are the equations in case you forgot them. So the equation that we're going to use is going to be this one. We're going to use 10 for g. Initial velocity is 0 because the acorn drops to the ground, so its initial velocity is 0. And then when it hits the ground here, the question is, what is the velocity? So the velocity there is equal to v naught minus gt. V naught is 0, so it's just going to equal to minus gt. Given the time is 2.5 seconds, so it'll be 25 meters per second, 2.5 times 5. So the answer is going to be over here, 25 meters per second. The next question is related to the same one. How far above the ground is the acorn if it took 2.5 seconds to hit? Stop the tape and see if you can do the question yourself. Again, these are the equations here. So the equation we're going to use is going to be this one here, because we're interested to finding delta y. And so delta y is going to equal to v naught t, well that's 0, because v naught is 0, it drops from the ground, minus 1/2 g, which is 10, times t squared, 2.5 squared. And so this will come out to be about 30 meters per second. About 30 meters. That's the height above the ground. 30 meters. Delta y will give you that number. Which of the following graphs represents the velocity as a function of time of an object thrown straight up? Stop the tape and see if you can answer this question. We've already tackled this question a couple of times in class. Of course, the velocity starts with a big number as it goes up, then gets smaller, smaller, and smaller until it becomes 0, and then it starts becoming negative. It gets bigger, bigger, more negative. And so this graph tells you that. It starts with a big number, it gets smaller, 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 smaller. It becomes 0 over here, and then it becomes negative, more and more negative as you go along. A ball is thrown straight up from the ground with an unknown velocity. It reaches its highest point after 3.5 seconds. With what velocity did it leave the ground? So stop the tape and see if you can do the question. The best way to start this problem is to write down what's given. So V naught is what you want to find. What else is given? The final velocity when it gets to the highest point is equal to 0, and the time is equal to 3.5 seconds. You know what g is, what acceleration is, and you're asked to find the initial velocity here. You know g also. So stop the tape and see if you can do the question. So out of these equations, this is going to be a pretty easy problem. You're going to use the first equation to find this. Putting in these numbers, you will find that V naught is equal to about 34.3 meters per second. So this would be the right answer. This is the calculation here. An arrow is launched straight up with a velocity of 12.6 meters per second. How long before the arrow returns to the ground? So it's launched over here at 12.6 meters per second, goes to the top and comes back here. How long a time elapses? So stop the tape and see if you can do the problem. So the equation to use, well, a number of different ways to do this problem. So what we're going to do is use this second equation. And we know when it goes up and comes back to the same spot, delta y, the change in coordinate, is 0. So you set this equal to that and calculate the time. You should answer the question, be able to answer the question. So here's the calculation here. We have V naught, which is 12.6 times t is equal to 1/2 gt squared, which is 1/2 g is 5 times t squared. So one of these t's cancels this t. So t is equal to 12.6 divided by 5. And that is 2.6 seconds. So this is the answer over here. The second part of this question could be how well could be how long. Well, this is how long the whole trip takes, 2.6 seconds. So that, no, there's no second part, sorry. So let's try this question, 16. A kangaroo jumps to a vertical height of 2.8 meters. So jumps with some unknown velocity to a vertical height of 2.8 meters. How long was it in the air before returning to the earth? This is similar to the hopper problem we did. So stop the tape and see if you can answer the question. So the first thing to do is to write down which equation you're going to use, and of course you're going to use that equation. If you look at it from the top to the bottom, okay, you could use that equation. Delta y is 2.8, and you can solve for the time and then double it to see how long the kangaroo was in the air. That's one way to do it. So if you double this number here, you will get 1.52 seconds. Of course, the other way is the same as we did the previous problem. Delta y is equal to v naught t minus 1/2 gt squared. So set this equal to 0, delta y 0, because kangaroo jumps up and comes down. Delta y is 0, and hopefully you get 1.52 seconds also.